Clean code is slow, but you need it anyways. I've already begun to disagree with the article. I'm gonna calm myself down. I'm gonna read this with an open mind. I'm gonna read it with an open mind. Okay, I'm gonna read it very open. Okay, here we go. So open. Beware. Clean code can clean anything. All images. Really? You know, you could have just chat GPT. I'm always so confused why people always have these like Unsplash and all this. You know, you can just dolly this image. This is it really that crazy? In case you haven't heard, something really interesting is happening in the programming software development scene on Twitter. It all started from one of Casey Moratori's video on performance-aware programming. By the way, that video, Clean Code, Bad Performance, was an excellent video. If you have not watched that video, you are truly missing out on a great video. Even though I don't agree with all the things he said, and I do think that he's gaming the system a little bit on the measurements, nonetheless, I think what he's doing is fantastic. Absolutely love this one. Okay, if you haven't seen it, please go check that one out. It's aptly titled Clean Code, Horrible Performance. Look at that. I know it so well. I memorized it. It stemmed from Casey's own criticism of modern software that runs at less than 1/20th of efficiency. This is a valid concern considering inefficiencies are the reason we can't get nice things, and also the reason why John Carmack left Meta. Then Uncle Bob, i.e. Robert C. Martin, chimed in and had a very thorough and educational discussion with Casey using GitHub. The discussion is still going on as of this day. It also spawned a thread on Hacker News. Okay. I have seen this video, and I think, although he is correct, he wasn't really painting the whole picture correctly. I take from his video that polymorphism and excessive single responsibility principle are slow and thus bad, which is true in a way. Since with polymorphism, there are costs for vtable lookups and indirection, and not to mention it will make the function and or data scattered around and not near each other. So it will cause L1 and L2 CPU cache misses. The big thing for me is that it doesn't just cause L1 and L2 cache misses. When you got data all spread around, just even like how clean code suggests doing it, it also scattered around for my L1 and L2s. You know what I mean? Like, it's very hard to hold in your head these very clean architectures, is that you end up having just so much functionality spread throughout the code that I personally find it is very, very difficult for me personally to understand. I don't have a very big L1 cache. Maybe I'm just too stupid for software engineering. People always tell me that when I say learn to type fast because it will help you be able to be a better software engineer because you'll be able to explore more code. I always get the same comment back, which is you just aren't planning enough ahead. Anyone that tells you this just simply means that they're not very good at software engineering. Maybe I'm not. Maybe I'm not a good software engineer. Me personally, I just can't hold that much in my head. I can never plan ahead very well. Every time I try to do clean code, every time I try to extract stuff, every time I try to abstract stuff, I always end up regretting it in some way or another, and it just ends up causing a refactor that's larger than the one that I initially started, that I could have just started with. And so it's just been one of these things where I'm really trying to uncomplicate my life, and I've been doing so for quite a few years at this point. That's not clean code fault. Of course it's clean code fault. Clean code has some restrictions and requirements for how you organize your items. And I often find breaking those principles can make things really easy. That's an L1 cache take. Okay, maybe I'm an L1 cache take. I don't know. Extracting a function into multiple private helper functions may also cause cache misses. So do inline functions. Unfortunately, polymorphism is the heart of solid principle and one of the key principles of clean code. I will say, though, that I do enjoy a good strategy pattern from time to time. Not gonna lie to you. I like a good strategy pattern, okay? So, do I always adhere to this? No. Sometimes you gotta do this. Plus, let's just be real here. I often am programming in TypeScript at my job, and this whole idea of dynamic versus static dispatch, polymorphic, all that kind of goes out the window when you're programming JavaScript, because it has to do everything crazy, because that's JavaScript. You know what I mean? That's just JavaScript. It's just crazy. All right, look at this. Really thinking on his computer. Look at all that thought. Performance is indeed important. Efficiency and performance are pretty crucial in performance-critical software like games and embedded systems, since no one would want to buy a 10 FPS game or a slow embedded device. I would argue it's also critical on things like Twitter. Twitter has gotten a lot better in the last few months, but just yesterday, using it on my phone, I used the web app, it just crashed. The page crashes because it just ends up using too much memory, and then all of a sudden it starts slowing down. You can start seeing the animation slow, and eventually over a course of time, it just crashes and explodes. So I would argue that it's actually pretty important in a lot more cases than simply embedded devices. Maybe not nanosecond important or microsecond important, but memory usage and efficiency are still very, very important. They might also be important for backends to server content as fast as possible. You gotta server that content, boys. And an inefficient app, for instance, will make your device slow and hot and consume more energy than it should. For the backend, it might also add to the cost of cores and or memories or additional services. And, you end up having to get a lot more machines, a lot of stuff. I'd reckon this will be something to think about in the future since startups can't really spend more than they should. The operational cost would be smaller if you can make efficient code. Fair take. There are many ways to make your code performant. First, choose the right algorithm. This may be the easiest one. Choosing the right algorithm might be a difference in getting your code to run like the Flash or Eeyore. So this is actually a really interesting one. I would almost go with the opposite here, which is reach for an array sooner than you are currently reaching for an array. What? You have a set of 20 items, and you want to see are they included or not? Use an array. Don't use a set. Right? Like there's like all these things that can end up happening that it's actually better to just use an array almost always. Like start there and then go from somewhere else. I can even be like a dynamic array in the sense that, let's see. Yeah, this is just faster. Yeah. It's one of those funny things that people just don't realize is that often you use complicated data structures because the O of n is cheaper. But the practical reality is that your O of n comes with a constant that's like 10,000. And so it's like, yeah, does that really matter when my other constant's 10 and it's n squared? It doesn't really matter for like a long time. Oh yeah, friendship ended with set. You should love arrays. Next, we can get help from the hardware itself, like using L1 and 2 caches or CPUs to make your code run faster. Again, we're speaking a foreign language to JavaScripters. L1 cache can run 100 times faster than your RAM, and L2 can run 25 times faster. But to do that, we must know how the function and data are laid out in memory, since you need them to be close to one another for a cache to take effect. We can do this using data-oriented design or entity component system patterns. You can read this link if you want to. I've always wanted to implement a little bit more ECS. I did like a rough version of an ECS pattern in JavaScript a while back, and it was really cool, and I'd like to do more of that. You know what I mean? It was kind of fun. Just learning about it. We can also get help from the CPU's instruction set extensions like MMX, SSE, or AVX. Phrases and instructions never said once by JavaScript developers. Airplane. All right, but clean code is also important. There are also paths to pursue than pursuing only performance. I have seen a lot of badly written and unreadable codes, and most of them are from my time as a game developer. As you know, game developers are notorious for pursuing performant code because it means you can push for more content, quality, tris count, textures, etc. to make the game look better without jeopardizing FPS. Okay, that makes sense. But I believe that if your only concern is performance, you may end up with buggy end product like the source engine in the infamous Coconut JPEG. I've always wanted to read this article, the infamous Coconut JPEG. This is something I want to know about, right? Why does this break when the coconut is gone? Why? Why is it gone? Where did it go? Is probably the result of a violation of the separation of concern single responsibility principle. So if you change one part of the code, it might affect another part that has nothing to do with it, with the part you are working on. The same happens with me and BlackBerry Messenger. There is a class in BBM iOS called BB Messenger. What are we talking about? We are forbidden to touch this class if not necessary. If we do need to work on it, thread carefully because it might break things. What, BlackBerry still exists? What is BlackBerry Messenger? Is this real? BlackBerry Boomer. You know, I'm a fan of Blackberries. I got a bush in my backyard, but BlackBerry Messenger I've never even heard of. What is this? They're a cybersecurity company now. Is their name Cyberdyne? Performant code is not the easiest to read and maintain. If any, it's often the opposite. Try looking at the Quake's fast inverse square code to get the idea. Although not all code is that obscure, I feel like this is kind of an unfair thing to point out. The fast inverse square biz that went on was an incredible hack to make video games even possible, right? Like, you really couldn't do these 3D games with much fidelity at all without, like, sucking out every last programming instruction of all time. It uses float magic, yeah. The Mantisa is getting abused in that one. But it's just like, it's kind of like a silly thing to point out the world's most extravagant performance hack as a reason why you shouldn't do it for maintainability. Like, you can write a lot of performance-based code without going to this level. And second off, it's not John Carmack that wrote this. It's his teammate. It's not John Romero. It's not John Carmack. It's the other guy. I don't remember who the other guy is, but it's the other guy. Can't go to the moon because it's hard. Yeah. Clean code and other modern programming principles are mostly concerned with development process rather than performance. They are used to cut programming time rather than performance. Their goal is to make the code more readable, testable, robust, extensible, and maintainable. Sometimes, most of the time, at the cost of performance. The reason is processor and memory are cheaper than development and maintenance time. And so, adding a processor and memory is recommended to compensate for the lack of efficient clean code creates. I'm kind of on the fence about this one because I think you can still make good code. I still think you can make maintainable code, and you don't have to follow clean code. I think people use this term clean code to literally mean code that looks easy to maintain. Those aren't the same thing, right? Clean code is in of itself a specific methodology for setting up everything. You reach for abstraction first. You don't inline stuff, right? It is like there's like this whole set of things you have to do in the clean code world that is different than code in which is clean. You can write pretty good performance code that isn't crazy, right? That really totally breaks down the whole notion of clean code, and I think that that's okay. I've tried writing clean code. Can't understand the code base anymore. Yeah, I mean, for me personally, I find that when I have a very clean code system, for me to understand the system takes significantly more amount of time. And I can think of one that just recently in my tenure at Netflix, even when we were doing this image processing and image grabbing for all the different tests and different assets we were doing for our originals, there was an entire system we built that was all very, very clean code principled in Java for the servers. Remember, we use Java. And I real talk, it took me a long ass time. I learned those patterns. I learned them. And it was still super hard for me to maintain everything required to understand what was happening. Eventually, obviously, I got part of it down and I could do some things and I could edit some stuff. But nonetheless, it was extremely hard for me to understand what was happening. And at the end of the day, it was all reaching for how to generate a URL. But there was thousands of lines of abstraction. Some of it needed, some of it for the pure sake that it was Java because of just how Java was. This was 1.7 days. But then, it goes from there. Skill issue. Yeah, no, it was full skill issue. You can quote me on that one. You could definitely say that it was a skill issue. How much lines of code was it? It wasn't the lines of code that makes it hard. It's the abstraction that makes it hard. When everything's a strategy pattern, when everything is behind a wall of some level of abstraction, for you to get to the thing that actually is doing the work just requires 2 to 3 extra hops in your IDE. So you go to each line of code and you have to jump. Okay, this thing is this. Okay, it comes from here, but okay, its config is generated from this thing, but that thing depends on, okay, it's actually an abstract builder factory. So okay, that means, and then you're doing this jump where you're actually having to build. Now I understand what went into it. Rather than, sometimes it's okay to just have a few things inlined to avoid the sake of abstraction. I like the idea that you should never really jump more than once or twice go to definition. Once you've done a 2-level go to definition jump, I think you've inherently built something that's too complex. Do a poll on how many people actually read clean code. Yeah, I think Uncle Bob has a lot of good takes. I don't want to dunk on Uncle Bob. I don't want to brag or anything, but he's recently been responding to a lot of my tweets. Okay, I think we might become best friends at any moment. Do you actually clean code? Did you read the book? Let's see. Yes, I read the book and liked. Oh my goodness. ambivalent, no, I know, read, good. Hot dog. There you go. And so for me, the biggest problem with a clean code always comes down to the same thing, which is not about performance even for me. It's about maintainability. I find it extremely hard to maintain once you reach a certain level. Ban everyone who doesn't agree with me, please. I actually recently saw a tweet. Theo said something nice to me, and someone within the comments was just like, Prime's going to probably do this. I don't even want to say what it exactly was, but he said something effectively like that. The moment he disagrees with me, though, I know he's going to do it. I'm going to absolutely hate him. You're just like, damn. Whatever. Where's the option to start the book and never finished? Probably under the disliked thing. How to answer the poll. You're going to have to figure that out. All right. Clean code. Oh, yeah. Let's see. Hold on. I have to say, when I switched my career from game developer to mobile, iOS mainly, developer and KMK Labs video, I got a pretty big shock because the paradigm in the office was different. So I've had a pretty hard time keeping up. Clean and maintainable is preferred over performance. The development process speed is more than the end products, but still is an acceptable value. So I've got to learn about clean code, solid, clean architecture, TDD, model view model, extreme programming, etc. Agile, Kanban, Scrum Manager. What does Scrum do? Who's Scrum? Why is there a Scrum guy? Why are we talking about rugby? I don't get this. Agile. The result is enormous, though. The development process is better. It is arguably faster. We've got fewer bugs. The team members can hop in and do their work in a class without worrying that they might affect the other people's work. The code is easy to read, and the cognitive load on the brain is lighter. We can extend features easily, and we can test them all easily. Okay. I mean, there's a lot of questions I have here, which I don't think you can answer easily, which is, I've been in code bases that are clean code that are extremely hard. I've been in clean code bases that are extremely easy. Both following the same principles, both doing the same thing. It's just that there comes certain problems which I think are arguably harder no matter what. I've been in code bases that aren't nothing to do with clean code, and it was simple to go through. Code bases that had nothing to do with clean code, and they were impossible to go through. I'm just not convinced there's no correlation, I don't think, between maintainability and perfectly following clean code. I don't think you can say that it's more maintainable. I don't think you can say you can deliver features faster. I just simply don't believe it. Being pragmatic and flexible is the key. We must mind both the performance and the cleanliness of our code. The code's cleanliness, readability, extensibility, and robustness are more important than performance. Since most of our routines are not the resource intensive, we can get away with some performance reduction and put in better structured code. This works except if we consider the burden our code will cause on our users' devices. How will it drain the battery, make it hot, etc.? But we must understand which part of our app needs performance. It is usually the deepest layers of our apps, where it is called hundreds and thousands and hundreds of thousands of millions of times. Yeah, like React, right? I mean, this is why I always harp on React. React is it is your core of your application, and it's lacking in performance. It's massive lacking in performance. Does weigh things down. Then we discard clean code for some performance-enhancing methodology. I don't even think you have to do that. I think you can do things without any of this. So in a way, other than clean code part, right? Clean code as in the proper clean code, capital C clean code. Know the basics. We do not need to understand what is happening inside the computer deeply. We must know what is happening under the hood good enough to judge how to work around our code. We also need to know the basics of our language and tools. Know your domain. Domain in software engineering commonly refers to the subject area on which the application is intended to imply. Duh. By having a deep understanding of the domain, we can understand what certain code is trying to tackle, and then we can code it to better suit the domain's needs. For instance, in the domain of hospital queuing app, we don't need nanosecond performance, so it's better to reduce our development time instead. It's different from a video game domain where we must render in real time. But even with that, some parts of the code need to do the opposite. Maybe real-time rendering of the queue number for the hospital queuing app needs performance more. Like all these things, like I still don't necessarily buy it. I like again, going back to Casey, what I really enjoy about Casey's take is that he does something he called it non-pessimized code, right? Where effectively what he's doing is instead of, by the way, thank you for the level 4 hype train. Okay, I'm trying to read an article here. I can't even like respond to this. Instead of always reaching for like, say, this extensibility, whatever tool that, this person's saying, instead reaching for just don't pessimize your code. Are you doing something that is completely ridiculous, right? Are you doing something? Are you adding a bunch of abstraction? Are you doing all this for the in-case future result in which you may at some point in the future have to change the code? That's probably not the best choice to make. Just write your code in a plain, straightforward fashion. Do you know what I mean? Like if you do that, you can avoid a huge amount of performance problems just writing it as simply as possible. I like clean code so much, that is why I take my computer in the bath with me. Feels, Beastcow. I don't recommend for anybody else. Yes, premature optimization is possible in both performance and abstraction. And I think that's where the whole clean code thing gets its problem, is that it puts on a way you should approach things. It just feels a little impossible. You know what I mean? The problem with clean code is that the bucket term people assign to whatever they think is clean. Yes. All meaning has been lost, and the term gaslighting used for everything. Yes. It's like the term gaslighting that's not actually used based off the movie Gaslight, in which you're trying to drive somebody crazy by telling them that reality isn't reality and constantly and slowly poking at them. Clean code / flaws should be a toolkit, not a religion. Well, unfortunately, this is programming, since the large majority of programmers have forfeited traditional religion. They instead have taken up the mantle of Vim and Emacs / clean code and solid and wet-ass code bases, wet-ass programming. And so that's their new religion. They need something to fight over. And so this is what we've done. It's pretty great. It's pretty fantastic. Vim is in fact religion. This is true. My religion is Arch plus NeoVim. See, there you go. I think it's unfair that chip engineers work their asses off to fit billions of transistors onto a small piece of sand just for software engineers to waste it. For me, this doesn't hit home. You know what I mean? I get what you're saying. Sorry, Emacs, as the Lord intended. Vim is not a religion. Vim is the one true path. And to suggest that others might be its peers is heresy. There you go. Thank you, Judo. Can you correct pick, please? All right. I don't... Let's read this thing right here. Do abstractions correctly. With proper domain knowledge, you can create a strategy for approaching the problem. After that, you have to do abstractions on the problem. Abstractions can define as hiding complexity and unneeded information for given context and just making the ones more relevant. Abstraction, in this case, is not just abstraction as in object-oriented programming. That is just one kind of abstraction. Variable types are abstractions. They are abstracting the bits that constitute the actual value in memory. Naming a variable is an abstraction. The abstraction, it is abstracting an unknown variable into something more relevant to the current context of the variable. Operations and functions are abstractions of register instructions. Okay, so this is the idea of this. This is like the world's most bland take. No offense. I mean, this is like you just said a lot of words without actually saying anything. Okay, do abstractions correctly. I'm going to say this. Don't abstract until you have a damn good reason to. There you go. Abstract correctly. I just gave it to you. You know what? Sit in a single file. Put 15 functions in that file. Do that until you kind of hit that point where you're feeling, I'm a little frustrated with my code, right? There's like this thing that ends up happening, and you can feel it. You know when it's happening, and that's a good time to rethink. You know what I mean? You got to give it a little bit of time. You got to let it cook. That's right. You let it cook a little bit. Hey, I just copy and pasted a function, changed some bits. I'm going to let that sit for a second because, we're just starting out. We're just exploring. I don't like that, but let it cook. So I'm going to go for a little bit. I'm going to kind of experience things. And then once all of a sudden at some point you're going to go, okay, here's the actual problem. The actual problem isn't those two functions. The actual problem's way over here. I'm going to go fix over here because now I understand the abstraction. And then you can move on. Just don't abstract too quickly. Wait for a damn good reason to. A real good reason to. Let's see, be pragmatic. At the end of the day, programming aims to deliver a solution to the users in the form of an app. Most certainly, we need to deliver what the user wants out of our apps or games. Maybe they want performant game with more than 100 FPS, or maybe they want an app with lots of features, reliable, less buggy, and deliver ASAP. We should be pragmatic with the tools that we have because users don't care how we do our job. You know the saying, with a hammer and nails. Yeah, don't do that. So what you're suggesting is a hammer and nail approach to the hammer and nails avoidance. Again, I'm not really getting anything out of this one. You know what I mean? I think that even the most ardent person that thinks that things should be pretty much done one way, even in their own little subsection, still is pragmatic about the various things they take. You know what I mean? And so this whole idea of being pragmatic, there's a level, people aren't avoiding pragmatism because they're like, I'm an ardent supporter of only this way. But they think that the other way almost always is an incorrect way of doing things and it will cause more headaches. It's almost never an argument of pragmatism. It's always an argument of familiarity or ability to kind of deal with a certain type of ecosystem. Okay, cool. I've had abstraction of the degen community. Thank you. I might be the abstraction. I might be more of the extraction of the degen community. Write everything in basic. Hell yeah. I don't know. I think that clean code is just not needed. At least that type of thing. But here's the deal. I'm gonna give a weird take at the end of this. If your entire team is doing clean code and all about it, learn to do clean code. If your entire team wants nothing to do with clean code, don't do clean code. Yeah, clean code is not needed, but solid principles good. Yeah, in general, solid principles are good. You got to know, you should mostly do that. You should try to make sure that you separate out. You just do a couple little things, and it's pretty good. I like it. I generally just program that way. It's better to just do what is currently being done than do what you feel is the best. That's usually my take on working with a team. Is when I work with a team, I just follow whatever they do, right? It doesn't matter what they do. I just follow that. You know what I mean? And if something is particularly egregious, I might try to refactor it and give it a shot, see what people think. I usually talk to people, though. Normally, because the thing is when you start refactoring something, you don't realize why it is, right? So you have to talk to people. And I'll ask, hey, can I refactor this part? And often people will be like, oh, yeah, it's terrible. Or, well, be careful because there's actually a lot of thorns in there and you'll probably end up at the same conclusion. And I've done that and I've ended up at the same conclusion. You know what I mean? I've been there. I've done that. Talk to the team. Yeah, exactly. Set aside time to do that. It's just better. Okay, hey, you know what? The name is I Don't Do Clean Code, but I think Uncle Bob he's probably a pretty good guy and Solid is pretty nice. You know what I mean? A jet.